Let's create a hypothesis test for a mean using the central limit theorem. So here I have a spreadsheet set up to do that. So I'm going to go through how to set up such a spreadsheet. To do a hypothesis test for a mean, you either need to know the sample size, the sample mean, the sample standard deviation, and possibly a significance level. Or you need the data and a significance level. So I'm going to start off with the data. So let's go to a new sheet and see what we can do. Wrong button. All right, so again, I need to calculate the count, how many items. I need to calculate the mean, the standard deviation, and I need to determine a significance level. I'm also going to need a null hypothesis. And so the null hypothesis is going to be this restaurant's collecting data on tips, and the maitre d', who's been kind of keeping track of everybody, says, I think it's $3. So maitre d' says mu equals, and we're going to put a 3 here. Now, you could say, oh, well, I think it's going to be greater than 3 based on some inkling or hunch, or you can say, I think it's less than 3. You could say it's not 3. So I'm going to go for an alternative here that the population mean is not. And I can't get a not equal to easily in a spreadsheet, so I'm just going to write it in words. Okay. So based on that, the type of test that I have is going to be a two-tailed test because it's not equal to. All right, so that's going to be important for when I calculate my p-value. Other things to consider here are, let's see, I'm going to do a t-test because I don't know what I don't have all possible tips ever, so I don't know what the standard deviation of all possible tips is for this restaurant. So we don't know the population, we only know the sample. So count equals count. Highlight your data by either highlighting the column or manually selecting the numbers. Mean, pretty safe to do that too, is average. Highlight the column. Standard deviation, I recommend you use STDEV, not version A, especially if you're selecting the whole column, otherwise you're not going to get the right number. And then I need a significance level. So, this isn't anything life or death thing, so I might go with the standard 5%, maybe even 10% for the significance level. It's not a big deal. So I'm going to go with 5%, maybe 0.05, which you could leave as a decimal or change it into a percent. Next thing I want to do is draw a picture of this. And I need a blank pad for that. So hypothesis test for mean, like the confidence intervals, we're going to make ourselves a rough sketch of a normal distribution. So we make that pretty bell curve. And in the middle, we're going to mark off our middle of 0 for a t-value. Okay. Now, when we're doing hypothesis tests, the middle is also whatever the null hypothesis is. In this case, my null hypothesis is it's 3, and that's like the scale for my x values down here. So 3 would be in the middle. We are looking at a two-tailed test. And so that means to calculate the p-value, my data is either going to throw me on this side or on this side. And it's the combination of this tail and this tail added together. So left tail plus the right tail for a two-tailed test is how you calculate your p-value, not just one like in a two-tailed test. So let's see what's going to happen here. So looking back at the data, we have 3.85. Okay, so let's see. So 3.85 is bigger than 3. That's going to be somewhere over here. And so I need to figure out what t-score goes with that to figure this out. So I don't know what that is. Once I find that t-score, it's going to be a positive number. Then I'll get the opposite of it over on that side over there. So let's make the calculation and see what happens. Oh, one more thing. This t-score right here that I need to find, that's what's called our test statistic in this case. And the formula for that is rather interesting. Test statistic. It is the sample mean minus the population mean, which is really the null hypothesis, that number right there, divided by, we could put parentheses around the numerator, be safe, parentheses around the denominator, the sample standard deviation over the square root of the sample size. So that's the test statistic for a mean when you don't know the population standard deviation, which you usually don't. So we'll use t's more often than z's for means. So let's give it a shot. So my t-score, let's calculate that. So that's the formula I just last wrote. So I need equals parentheses for the numerator. That is the sample mean, that's x bar, minus the population mean, which comes from the null hypothesis. And then I want to divide that by the standard deviation of the sampling distribution, which is an approximation of that is the sample standard deviation over the SQRT of the population size. Close the square root, close the denominator, hit enter, and I get a t-score of about 4.396 if I went to 3 decimal places. So back to my picture, the t-score here is about 4.396. So that's how many standard deviations this number is to the right of believing the mean is $3. So 85 cents higher is 4 standard deviations higher for a sampling distribution, right? That's what I have here, a sampling distribution of psi with n being 157. All of that is relevant. All right, so next we need to calculate the probability of this tail right here now that we have the z-score. So this is kind of complicated. Let's do that next. So my spreadsheet kind of takes these things in order. So I'm ready to start finding the p-value. So p-value, that is equal to a t-dist. T-dist takes a t-score, calculates a percentage. So equals t-dist. And for a t-dist, I need to know what the x value is. That's your t. That's right there, comma. Your y value, sorry, your degrees of freedom, that's the count minus 1. So count minus 1. And then how many tails am I calculating for? And this is kind of cool. I can just do a 2-tail, get both of them at once. So I don't have to worry about any doubling. So it says it's going to be ooh, look at that, it's little. 0.00002, did I get that right? 1, 2, 3, 4 zeros, then a 2 is the p-value. I'm just going to double check that by doing a single tail, see if it's reasonable. So t-dist value is my t-score. Degrees of freedom is 157 minus 1. And let's do a 1-tail. We should find that's half as much. Good. Okay. So in my picture here, I found that this left tail probability over here is 0.12341, which means this one over here is also a probability of 0.00001. That would go with a t-score of negative 4.396. On spreadsheets, the t inverse will never give you a negative t-score. It's always going to give you the positive version. And when you plug in a t to the inverse, did I get that right? No. When you plug in a t to the t-dist, you always plug in the positive version of the t-score. It's a little tricky. We'll have to do some more examples. But just beware. So together, they give me my p-value. So the p-value altogether in this case, 0.12342, which is pretty damn small. So whenever you get a small enough p-value, then you get to reject the null. The null was the maitre d' saying it's about 3. Well, we found that our particular sample had what, like $3.85. So the question is 85 cents more than $3 significantly more? And for 157 tips as the sample, yeah, it is. So what we've established is the tip isn't on average $3. And since our alternative hypothesis is which we get to accept when we reject the null, since our alternative hypothesis, alt call H1 was that P was not 3, then all we can say is we have significant evidence that the mean is not, that the proportion is, sorry, no, this is a mean, excuse me, mu, that the average tip, significant evidence that the mean is not 3. Now, I could run a different test. I could say, hey, why not run a right tail test? Right tail. If I was going to run a right tail, my alternative hypothesis, we call that H1 or HA, that would have to be mu is greater than 3, which means I can only look at the right tail in that calculation. So, and sometimes people change their minds on the fly when they're making these. So I found a t-score of about 4.3-ish. Tail probability was 0.00001. It's still a wicked small probability. So what that means, again, I was expecting 3 in the middle for the average tip. I found a sample that's 385. So is 385 significantly more than 3? And the answer is yeah, because the probability of getting that is so damn small, something must be wrong with 3 in the middle. Okay, so even with a right tail test, we get to reject the null here. And then we could say, the tip's more than $3. Can we say it's 385? No, but we could do a confidence interval to secure an estimate of what it is. So they're kind of related. That's it for now. Hope this was informative. Have a good day.